It's reality. First ever wormhole has finally been discovered. There are many intriguing things in deep space, and one of them is wormholes. For many years, scientists have speculated and researched wormholes, but they have now finally found the first ever wormhole. What is a wormhole? Why are astronomers so excited about it, and how does the discovery affect you as a person? In this video, we bring you the first ever wormhole discovered by scientists. Many humans may not know how much work the Earth does in protecting us. Thanks to its unique features, we are kept safe from what would definitely kill us. However, once you step out of the planet, all bets are off, and the deeper in space you go, the more scary things you encounter. One of these things is a wormhole. A wormhole is both fascinating and scary, as you shall see. Thanks to their unending fascination, scientists have uncovered many things about wormholes and even created one. But what exactly is a wormhole? A wormhole is actually a solution to the equation describing Einstein's theory of general relativity, which connects two distant points in space or time via a tunnel. However, in this case, the tunnel's length is shorter than the distance between those 2 points, which means you can refer to wormholes as a shortcut between 2 points. For many years, wormholes have remained hypothetical, even though they have appeared in many sci-fi films. But of course, that's no longer the case. With the recent discovery, you might have heard of wormholes, referred to as Einstein's Rosen bridges. That is because the simplest possible wormhole solution was discovered by the great scientist Albert Einstein and Nathan Rosen in 1935. The duo started with a mathematical solution of a black hole, another terrifying phenomenon. A black hole consists of a singularity or a point of infinite density coupled with an event horizon region surrounding their singularity beyond which no object can escape. According to the physics of the universe, they found that they could extend the solution to include the polar opposite of black holes, white holes. These white holes also contain a singularity, however, they act in reverse to a black hole. They don't allow anything to enter their event horizon, and any material inside a white hole gets spit out immediately. Now, this is where the wormhole comes in. Einstein and Rosen found that for every black hole in space, there is a white hole. However, because the two holes would exist in separate places in space, a tunnel would bridge the two ends. This tunnel is known as a wormhole. However, while wormholes can exist, there was a challenge: stability. A single photon or particle of light passing through the wormhole tunnel would introduce so much energy to the system that the tunnel would snap apart, destroying the wormhole. Also, if you have thought of a wormhole as a cozy, secret passage you could take from one corner of the universe to another, you might be mistaken. Since you can only enter from the dark hole side, you would cross the event horizon and you would never be able to leave. This would mean you would be trapped in the corresponding wormhole for eternity. But scientists eventually found a way to make a stable wormhole and even make it traversable, meaning a mathematical equation or two will rescue you from being an eternal prisoner in the said wormhole. The trick discovered in the 70s is to move the entrance of the wormhole tunnel beyond the event horizon of the black hole and to stabilize the tunnel itself so that matter passing through doesn't cause immediate catastrophic collapse. To stabilize a wormhole, scientists discovered you need what is called exotic matter, or some form of matter that has negative mass. Recent research found that wormholes containing exotic matter could stay open and unchanging for longer periods of time. Negative mass is an interesting concept. For example, if you place an object with a negative mass besides a positive one, it will immediately accelerate even without any source of energy. Mind you, exotic matter is different from dark matter or antimatter. There's also the problem of size. Primordial wormholes are predicted to exist on microscopic levels, about 10 to 33 centimeters. However, as the universe expands, it is possible that some may have been stretched to larger sizes. But let's pretend you find yourself inside a wormhole. What will you see? Scientists discovered it would be strange. The entrance would be a sphere, like you were looking at the surface of a planet. If you looked into the wormhole, you would see light coming in from the other side. The wormhole tunnel could be any length, and while cruising down the tunnel, you would see distorted views of the region, the universe you came from, and the region you were traveling to.